be solving Leetcode 3011. The question name is find if array can be sorted. It is a medium level question of Leetcode, but the question is saying that you are given a zero index array of positive integer nums. In one operation, you can swap any two adjacent element if they are not if they have same number of set bits. You are allowed to do the operation any number of times, including zero. Return true if you can sort the array, else return false. So, for example, we have nums like this: 8, 4, 2, 3, 30, and 15. Number of set bits in 8 is, so it can be represented as this. The number of set bits for 8 equal to 1. Similarly for 4 it is 1. For 2 it is 1. For 30, if we calculate, 30 can be represented as 16 plus 8. So basically 30 can be represented like this. So it has 4 number of set bits. Similarly with 15, it has 4 number of set bits. And these are the set bits for each element. So we can only swap two adjacent element if they have the same set bit. So if we perform operation on these three, as they have the same set bit, we can just perform any number of operation and sort these. Okay, and these set of elements also have the same set bits, so I can also sort these independently. Now after sorting this, I will check whether the last element of this is smaller than the first element of this. Let's say if there is something 15 over here. I'm not talking about the set bits. Let's take, there is some element, we can take 64. Let's say we have 64 here. Okay, and we have 15 over here. After sorting this, I am getting this 64, which is greater than this, and these two elements cannot be swapped because number of set bits here is 1 and number of set bits here is 4. So these two numbers cannot be swapped ever. So these two elements cannot be sorted ever. So therefore for this my answer will be false if my particular nums array would be given like this. Okay, so what is the intuition? So how we will be performing this is, first of all, I will calculate the set bit of each number. I will calculate the set bit of each number, and I will set, so just basically we should look at the code. So this is the code, this is my class solution. I first of all constructed a get bit count function, which is taking nums as my parameter, and it will be returning the count of number of set bits. First of all, I am initializing my count to 0, and I will perform the operation till my number is greater than 0. At each operation, what I am doing is I am checking whether last bit of my number is set or not. If it is set, I will add it to the count. AND operation will perform the AND of the last integer. So let's say my bit representation is like this, and I will perform the AND with this. So it will give me 0, the last index only. But if it is 1, it would have given me 1. So if I add all the set bits to the count, so but it will be 1 2 3. So at last I will be getting my count as 3. Okay, and at last I will be returning this. At each operation I am also doing the right shift of the number by 1. This is my function, this is my main function, can sort array, which is taking my nums. I'm first of all setting my current max equal to nums and my current min equal to nums. So like basically in this example, let's take new example 2 6 64 15 30. Okay, number set bits here is 1, here is also 1, here is also 1, here is 4, here is 4. Okay, so at each operation what I'm doing is first of all setting my current maximum equal to this 4, the nums of 0, and my current min is also equal to 4, and also I am storing the bit count of my current, which is equal to 1, and I will performing the traversal for my second index. Now when I will reach my second index, I will first of all check is my bit the bit count of this and my previous bit count which I have calculated is same or not. So 1 is equal to 1. So what I will do is I will update the current maximum and current minimum. Current maximum will be same 4. My minimum will change from 4 to 2 because 2 is smaller than 4. Then I will increment my I over 64. So 64 has the same bit count. So I will change my current maximum, current minimum. Current minimum will be same 2, and current maximum will turn into 64. Now I will iterate, I will increment my I. It will reach 15. I will check whether the bit count of 15 equal to my current bit count. No, it is not. Then what I will do is I will check whatever the maximum of my previous subarray, whatever the maximum of the previous array should be smaller than the current maximum. Okay, so first of all, previous maximum initially I have stored as integer dot min value, integer dot min value. So whenever I will reach this, I will check whether my previous maximum, which is the minimum value, is smaller than my current minimum not. Previous maximum is I am storing this. So currently my previous maximum is smaller than my current minimum. So it is true. So what I will do, I will update my current maximum with the current maximum of my previous maximum with my current maximum. So it will turn into 64, and I will set the bit count as 4 over here, and I will also set the current maximum current minimum to 15 only. Now I will increment the I. It is 30 now. I will set the current maximum as 30. As the bit count is same, so I will just update my current maximum. So after performing all the traversal, I will then also check whether my current minimum is greater than previous maximum. So this the smaller of this should be greater than the maximum this. Then only we can sort the array. But in this case, my 64 is greater than my 15. So in this case, our answer will be returning false. So similarly, I have done over here. First of all, I'm setting the pre-bit equal to the get bit count of nums of 0. Maximum current, maximum previous is set now as the integer dot min value. I am iterating from the first index and setting the bit. I am first of all calculating bit count of the current element, which is the ith number at the ith index. Then I am checking whether the bit count is same as the previous bit or not. If they are same, I'm just updating my current maximum or current minimum. If they're not same, first of all, I'm checking whether my current minimum is smaller than maximum of previous. If it is not, I will straightforward return false. Then what I'm doing is I'm setting my max previous as the current maximum, and I'm also setting my current minimum as the current number, and my current maximum also as the current number. My previous bit will be set as the current bit. After performing all the operations, I will again check whether my current minimum is smaller than maximum previous, because after traversing for the last element, we are not checking for the last element. So after traversal, it is mandatory for checking whether the last indexed is also valid or not. So I'm also performing this operation over here. So current minimum is smaller than maximum, smaller than previous. If it is, then I will returning false, else I will be returning true.